Hello, my name's Steve Mace from Solwise, and what I'm going to do here is run through a PowerPoint presentation file going over the various aspects of the IP.com AC3000 AP Controller. So this follows on for the videos that I've already done on the sister products, being the AC1000 and 2000. But the 3000 is a completely different kettle of fish. The 1000 and 2000s are more what I would call AP configurators rather than AP controllers. So they allow you to do block configuration either on groups of access points or singly access points, and do things like firmware updates. But they are still just a tool of actually managing the configuration of the access points, not necessarily, for example, the client connectivity through the access points, or the data flow from the clients going through the access points, more just the absolute configuration of the access point. Now the 3000 wraps that up quite a lot. The 3000 not only gives you all the tools to actually monitor and configure and manage the firmwares and everything else on the access points, it also gives you very sophisticated tools for traffic management through the access points. So that's traffic management to and from the connected clients. So it's got some very powerful features and functions to enable that. It's a sort of features and functions really designed for very large scale enterprises. I'm talking about not necessarily the site here that needs maybe 30, 40, 50, 60 type access points, but the sort of site that needs very high numbers of access points, potentially up to thousands of access points, and or thousands and thousands of actually connected clients. So we're talking about very large scale enterprise solutions, like for example hotels, very large companies, the sort of installations where you want to have key management and control of the data throughput and the data streaming to the clients, etc. So much more sophisticated kettle of fish. So let's go through here. Let's click on the next side. So as I say, there are two sister products. That's the 1000 and 2000. The main difference between the 1000 and 2000 really is the number of access points that it can configure. The 2000's got a couple of extra features as well, but the main difference is the number of access points that it can control. Now, if we look at the 3000, they've done three different models, all built around these sturdy, great big rack-mounted chassis with some powerful processor board running inside it, hard drive storage and everything else. And the difference between them comes down to the number of access points / clients that they can actually support. So that's they're all essentially the same sort of big black boxes, but the difference is the capacity and power of the processing engine inside and the maximum of data throughput that they can cope with. So just to recap again, so the 1000 typically for small businesses up to a maximum 128 FAT APs. Key phrase there, FAT APs. So we'll discuss FAT and FIT APs later on in the presentation. And the 2000 up to 512 FAT APs. To recap on the AC1000, we're talking about managing up to 120 APs. It can automatically find and configure the APs. It's got various tricks to try and optimize RF channel usage by the APs. It can manage a range of indoor and outdoor APs. It's got layer 2 roaming and some stats for AP and client usage, and email and software alarms. If you look at the 2000, main difference is we've increased that maximum of access points up to 512, and also they've added a limited function captive portal server with customized welcome page. Now the 3000, as I say, is designed for very large scale installations. So we're talking about luxury hotels, shopping malls, large businesses, public services, anywhere where you need a very large number of access points and a very large number of connected clients and control of those clients. So there are three different models. The difference really is the processing engine that's inside. So what that does is that limits the number of access points that it can cope with. And as you can see here, if we go right up to the top of the range here, we can cope with up to 3,000 access points. And interestingly, the 3,000 access points can actually be spread across different sites. So yet again, that's another function that the 3,000 can do that the other products can't do. Maximum number of authenticated users, so we can go up to some stupendous number here like 50,000. The maximum of concurrent connections, yet again we can go up to some stupid figure here like 500,000. The main difference between them, I say, is the processor engine inside, and what limits these figures like the number of connection users is the maximum packet forwarding rate it can cope with, which on the lower model is 90,000 packets per second, and it goes right up to 2 million packets per second on the top of the range one. The rest of the specification is pretty much the same for all three. So it's got multiple WAN port capability. You can do heat maps for AP and RF coverage, channel-less, customized support authentication pages, automatic channels sorting out, very sophisticated roaming, load balancing, various methods of captive portal, etc. Next slide. So, main feature of the AC3000 are, now started off with the key difference. The key difference is the 3000 can cope with centralized forwarding using fit and fat access points. So centralized forwarding means that the data flow from the client, instead of going through the access point and thence on directly to the destination, be it for example your internet router, that's what they call distributed forwarding. With centralized forwarding, what happens is the data from the client, which is intended to go to the router for the internet, doesn't go direct to the actual router. What it does is it goes to the access point. The access point then forwards it to the client, to the access controller, and the access controller then forwards it on to the router. So all of the client traffic is routing through the controller. And obviously that immediately means that the amount of control and QoS and analysis that you can do to the data flow from the client has escalated enormously. You can do a lot with that data when it's all being routed through the controller. We've also got the idea of fit and fat access points, which I'll come to in a minute, but basically what they are whether the access points are self-autonomous. That will be fat access points. They're the access points you're normally used to in the normal world. And fit access points, which basically means that the access point has virtually no built-in intelligence, and it's all controlled and sorted out by the controller. It's also got airtime fairness to provide equal Wi-Fi access to the clients. It's got that ability to actually work out best operational channel. It can be used as a local management or multi-location, multi-branch management. It's got very sophisticated roaming. It's not just got layer 2 roaming, but it's also got layer 3 roaming. So that's roaming at the IP layer, which if you think about it, is bloody complicated. But yet again, it can do that because all of the traffic is actually going into the AC3000. So roaming is really easy once you've got the traffic coming into a centralized location. It's got load balancing, and it's got the same captive portal but with a few extra frills on it that you saw in the 2000. So fit and fat mode access points. So a fat access point is what you're generally used to. So these are access points which are what they call an autonomous architecture. Basically, the access points have enough intelligence built into them that they can sit there and operate as standalone pieces of equipment. They can be configured by a controller, but once they're configured by the controller, there's no real reason why they can't actually just sit there running perfectly okay with their built-in configuration. Now, fit access points are different. Fit access points, essentially all they do is they have enough built intelligence to cope with the translation of Wi-Fi to LAN and back again traffic, be it encrypted using WPA2 or whatever Wi-Fi security you're using. But as far as other aspects, for example, traffic routing and forwarding, FIT APs don't have the built-in intelligence to do that. All they can do is, all they know is, if I get some traffic on my LAN port, I throw it out on the Wi-Fi. If I hit some traffic on the Wi-Fi, I throw it out on the LAN. What happens to that traffic, how that traffic is used, for example, they don't understand Vlan tags or anything like that. All they understand is the translation of traffic from Wi-Fi to LAN and back again. So let's go through. So to recap, a FAT access point integrates the WLAN physical layer functions, aspects of data encryption, user authentication, QoS, network management, roaming, everything else is all built into the access point. A FIT access point has the encryption radio functions, and that's it. It can't cope with all this QoS, it can't with network management, it doesn't understand roaming, all that's completely thrown out the window. All that has to be done by the controller. A FAT access point can function in a completely independent mode. So the channels and the power in each access point can be configured independently. The AP can work independently. It does not need things like access controllers there or anything like that to work. Quality on WLANs, though, is difficult to measure because each access point is just thinking of itself. It's not necessarily directly communicating and interacting with other access points on the network. Now, FIT access points must have a controller. You take away a controller, a FIT access point won't work because they do not have the built-in intelligence. So it's up, for example, to the controller to allocate things like channels for AP groups, to control transmit power, to control features like roaming, be it layer 2 or layer 3. But as such, it does mean that it's very, very easy to do management of those access points because they're all being centrally controlled and managed by the controller. The controller knows that if it changes something on one access point, it knows directly how that is going to interact and affect some other access point. So much tighter control over what the access points do as part of RF allocation, client roaming, etc., etc. As far as the management maintenance is concerned, the FAT APs have a typical, genuine, normal graphical user interface built in. And although you can use a centralized controller to do things like AP configuration, outright management can be a little bit more complicated. The FIT AP is configured and delivered by the access controller, which means it's much easier to do centralized management of the APs. Application FAT AP, typical SOHO, small scale. FIT AP, typically aimed at the larger enterprise. Now, the AC3000 supports both operation with FIT access points and with FAT access points. But if you're going to use it for FAT access points, then you're wasting your money on it. If you're going to use it with just FAT access points, then all of the extra functionality and sexy features built into the 3000 just get completely thrown out. So, in fact, if you're going to use it with FAT access points, then say you might as well just go by the 2000 or the 1000 model. However, it can be used with FAT access points. In fact, out of the box, all of the IP COM access points come as FAT access points. So what you would normally do is you first of all run the controller talking to the FAT access points and do a process of firmware update on the FAT access points to change them to FIT access points. And from that point on, you can actually use the controller in FIT AP mode. So let's have a look. So as soon as we change to FIT mode, these are all the extra functionalities that we get. Sophisticated QoS management, sophisticated RF plans, the ad pushing portal, lots of extended AP and user stats. We get email notifications, we've got NAT router functionality, and we've got the cloud and cross subnet support. There's more functions and features, but this is a sort of indication of the extra functions that you actually get when you switch over into fit mode. So, by default, as I say, out of the box, all the access points come in FAT mode. So what we have to do, you first of all have to change your FAT access points to fit access points. So that means APs are switched to fit access points. The APs are then set to obtain an IP address from the controller and then managed by the controller. And once that happens, the default SSID policy and default RF policy built into the controller are then pushed onto these fit APs. So the process of doing this is you first of all you have to upload the AP's fit firmware into the controller. To do that, you go to the IPCOM website, link here, and you download the AP's matching fit firmware file. So when you go, you see this screen here on the access controller, you go to manage firmware, you click on browse, you then upload that file that you've downloaded from the IPCOM website, and when you click on upload, what actually happens is that firmware is then loaded into the memory or the drive built into the AC3000 controller. Then what you can do is you can then switch the controller, make sure it's in what is called old firmware mode. You log into the Web UI, you click on the Manage AP Modify, and you'll see a list of all the FAT access point currently being managed by the AC, and you select them and click Switch to Fit. What it then does is it does a process of updating each of them with that fit firmware that you have uploaded. Okay. Now, once they're uploaded and changed to fit mode, they are no longer visible in the FAT operating mode of the controller. So what you do then is you then change it to fit viewing mode, and then they will actually be displayed and shown. Okay, complicated. Centralized and distributed forwarding modes. Now, I'm going to be the first to admit here that I've been, I did not get this straight away. I've certainly been thrashing my head about out of it and been reading various online resources. Cisco is one of the resources I've been reading, because Cisco are really into this thing of what is called centralized forwarding access points. Also, Huawei are very much into controllers and management units based around centralized forwarding mode access points. So remember, centralized is where all the data from the client gets channeled through the controller. Distributed is where the data bypasses the controller and goes straight from the client through the access point to the final destination. For example, that could be the internet router. But hopefully this will be better rammed home with a few series of PowerPoint slides. So let's look at these two aspects of it. We've got centralized forwarding versus distributed forwarding. So in distributed forwarding, you configure the APs, and from that point on, the client then sends the data through the access point, and the access point then forwards it to the ultimate destination. So if the client's trying to get onto the internet, he says, right, I want to send the data to the default gateway, be that 192.168.1.1 or whatever, and the AP then looks at its routing table and sends that data onto the router and hence to the outside world. So what will happen in practice is you'll still use the controller as a tool for configuring the access point, but after it's been configured, the flow of data bypasses the controller and goes straight from the client to the ultimate destination, which in this example is the internet through the default router. Now, centralized forwarding, a little bit more complicated. So what actually happens is there is a tunnel connection from the AP to the controller, and then the client's data is encrypted and sent over that tunnel to the controller, and then the controller, in this instance, would forward it on to the router to the outside world. So, configuration, controller configures the access point the same as before, but now there is a tunnel set up between the client through the access point and through any intermediate infrastructure to the controller. So this is a private tunnel set up over which all of the client's data in encrypted format is sent to and from the controller. So if the client wants to actually connect to the internet, he actually sends his data through this tunnel first of all to the controller, and then the controller sends it to the internet. So data from the client over the tunnel to the controller, and then the controller looks at the ultimate requested destination for that traffic and then forwards it on accordingly. So in this case, through the internet, through the router, and from there onto the internet. So differences here, you can see all the data in centralized is going routed through the controller, and it's obviously that's going to give a far higher level of quality control and management of that data flow between the clients and in this case, for example, the internet. So the values of centralized forwarding are simplified deployment and implementation. The data is analyzed centrally to make sure the data is visible and controllable. So that's all the data being routed through the actual controller. The data is 100% encrypted. So from the time the client sends the data to the access point, from that point on, that data is encrypted over that private tunnel. Because all of the data is actually located and being routed to the controller, it means you can easily do roaming. You can even do roaming between VLANs, assuming of course you've got the appropriate permissions to do that. And you can also do things like data remote access management, just by actually doing remote management to the controller. So this is showing a typical example where you've got, let's say you've got multiple SSIDs, each with a VLAN tag. So if we had a network which is using two different SSIDs with VLAN tag 100 and 200, if we use distributed forwarding, the AP has to be made aware of those SSID and VLAN tags. And because the data is from that point on got the tag attached to it, all of the intermediary architecture, be it the switches, the router, etc., everything has to be aware and be programmed to cope with those different VLAN tags. And as anybody would know, if you've been playing around with VLAN tags, it can be a nightmare configuring the switches to cope with VLAN tags. It can be a real so-and-so. And it's made even worse because you will find that each different make, model, brand, manufacturer of switches will have their own way of actually configuring VLANs on their equipment, and will invariably use their own terms for describing various aspects of the configuration. So you learn how to do VLAN tagging on one make of switches, let's say they're HP. You then change to a different make of switches, let's throw a name out there, Ingenious for example, and you'll find that everything you've learned for the HP you largely have to throw away when you start playing around with the Ingenious products. It's just the way VLAN tagging is, it's complicated. However, if you use centralized forwarding, then all the VLAN tags only get applied when it gets to the controller. So all this intermediary equipment doesn't have to know anything about VLAN tags. As long as you set up the controller to cope with the VLAN tags, then from that point on, it's dead easy. This is just going over it and again reiterating what we've learned or what we've covered so far. So with centralized forwarding, there is a control tunnel and there is a data tunnel. So there's a control tunnel between the controller and, for example, the access point, and then there's an actual data tunnel for the client's data from the access point going through to the controller. So the flow events are, first of all, the client connects to the access point. So we're at this stage here, this item here, user connects to the access point. The AP then converts the Wi-Fi to LAN. Okay, and then the encapsulated packets are then forwarded by the AP over the tunnel to the controller. The controller then de-encapsulates the packets to normal LAN traffic, checks its own routing table, and then forwards the packets to the intended destination. When data comes back the other way, all that happens is you get a reverse of that process. Now, if you have distributed forwarding, then there's only one control tunnel, and that is the control tunnel between the access point and the AC controller. The data from the client is routing its own way, it's a little diagram here, routing its own way out to the outside world. So what happens in this instance is the user connects to the AP converts the Wi-Fi to LAN packets. It's then the AP's responsibility to check the forwarding table of where that data should be sent to, and then the AP that forwards it on to the ultimate destination and also does the reverse of any data coming back. So at no point is that client data actually going through the controller. It's all being handled bypassing the controller between the access point and the destination and back again. So one of the advantages you get with centralized forwarding is simplicity of network equipment management. I'm talking about on the hardware side. So for example, if you need to replace an access point with a distributed forwarding, then you would have to configure each access point with the various aspects for it to work, for example, Vlan tagging and that sort of thing. With centralized forwarding, the APs don't know anything about Vlan tagging, so there's no configuration required for the access point, so you can just literally just drop in a replacement. If you want to add an SSID, yet again, this is an SSID with a Vlan tag. What you would have to do is, after you configure the access point with details of the SSID and the Vlan tag, you would then have to sit down and start playing around with all the intermediary switches to actually cope with those Vlan tags. Yet again, on centralized forwarding, because the VLAN's all controlled by the controller, the only thing you have to do is just add a new VLAN configuration inside the controller. If you have to replace a switch, well, if you have to replace the switch with distributed forwarding, you're going to have to take all those VLAN configuration settings and transfer them over to the new switch. A nightmare. With centralized forwarding, you've only got one VLAN, and that's the one used for the actual control traffic. After that, you don't need to do any more VLAN configuration. If you want to extend the network, yet again, you've got pretty much the same as you do with a switch. You have to configure all of the VLAN settings. Yet again, with this, you only need to have that one VLAN port configured for the AP management. So the question comes, now, I think the answer to this is obvious. Is centralized forwarding better than distributed? Well, I think definitely. The reason being is all the AP and client data passes through the controller. The network infrastructure maintenance is easier, VLAN setup is considerably easier, and because all that data is going through the controller, you get a fantastic level of traffic monitoring and QoS. On the downside, because all the data is going through the controller, then there might be a performance issue with the network. Obviously, the infrastructure, that's the network infrastructure to and from that controller, must be able to cope with all of the client traffic going through that point. And because it's all going through that point, you potentially have an equipment failure weak point. If your controller goes down, then it's time to pack up shop and go home. nothing will work. You are 100% relying upon that controller. Also, this is linked really to this first point here. You may get a slight degradation in performance, but obviously if you've picked the network infrastructure accordingly, then that really shouldn't apply. Now, the AC3000 can cope with a centralized or distributing forward, either specifically one or the other, or in a mixed environment. So you can actually do centralized configurations and distributed forwarded configurations running side by side at the same time. So the question comes, when would you use one, when would you use the other? Now, the thing to think about is when you do centralized forwarding, all the client data is going through the controller. So any example you can think of where you need to have ultimate control and stats on client data, that's when you need to be using centralized. If you don't care about knowing so much exactly all of the data and ultimate QoS of that client data, then you can use distributed mode. So if we give an example here, let's say we're doing an ISP WLAN network. Now, the thing about an ISP is he wants to know to the nearest packet exactly the amount of data and the usage of that data of the clients. So in that case, they want to be using centralized forwarding mode. However, in a business environment, you don't necessarily want to have that nitty-gritty, detailed knowledge of exactly the client data flow. You need to have some control over client connectivity to the access points and that sort of thing, you know, SSID passwords, maybe even radius passwords or something like that. But as far as actual tight control using QoS or similar of that client data, it's not that important. So in those instances, you'll probably go for distributed forwarding mode. And the third example we've got here is where you need to have two classes of users. So that's saying, for example, a school campus or a college campus or something like that. But typically an educational environment, or even particularly a hotel environment, but where you've got two classes of users. You've got, for example, guest users for internet access, and you've got staff users. And in those instances, you probably want to mix the different modes. You probably want to have some SSIDs set up for centralized forwarding mode, for example, for forwarding internet service data, but you might want other SSIDs set in distributed mode, for example, for members of staff or something like that, or intranet or something like that. So let's go through the flowchart for the configuration and the differences involved in the different configuration modes, depending on whether you're in centralized or distributed. So in centralized, the first thing that you may need to do is configure the Vlan interface on the AC controller. Now, if we go back to that example, I shall go back to that flow diagram. Where is it? That one will do. Yeah, that will do. That will do. Let's go to that one. Okay. So, in distributed mode, the client through the access point is talking through to the internet. So in this case, the client data will go from the access point to the router and hence to the internet. So if there's any VLAN requirement for connecting to the router, then obviously the access point has to know about that VLAN tag. If you go in centralized forwarding, the AP doesn't have to know anything about the VLAN tag, it's the controller. So if you were setting up, if your export router, your internet router used a VLAN tag, then you have to tell the controller what that VLAN tag is to get out traffic and connect to the router. So if we go back to that example, where is it? That's what it means here. So if you're in centralized mode, you may have to configure a VLAN interface for the controller to connect to the internet router. If you don't use a VLAN tag for internet traffic to the router and hence to the outside world, then that stage can be completely ignored. Then, next stage is, do you want to assign the IP address to the users by the controller, or do you want to use your another DHCP server on site? If yes, then configure the IP of the DHCP server. If no, go straight to configure SSID setup. Once you've configured an initial SSID setup, do you want to set up other SSIDs? In which case, yes, just go in a loop, configuring all the SSIDs that you want. Once you've configured all the SSIDs you want, then you would actually create your group of access points and then push that configuration onto that group of access points. So that's centralized mode. Now, distributed mode. A little bit more complicated. Although you don't have to worry about that VLAN at the start, you do have to worry about the VLAN on each IP interface. So, assign IP address for users, yes, right, configure it. You may not be using VLANs, but let's say you're using VLANs. Configure the VLAN interface, configure the DHCP server, and from that point on, then go to configure SSID policy, and from that point on, it's the same as when you were using centralized mode. So the difference is whether the controller has to know about the VLANs or whether the clients have to know about the VLANs. Let's just go through those examples again. So this is a typical example where you want to use centralized forwarding. So this could be a setup where you've got guests connected to Wi-Fi and you only want them connected to the internet, but you don't want to use a Wi-Fi password. So in that case, you'd probably set up a guest access SSID and set it up for centralized forwarding mode so that the controller is aware and can manage and investigate all of that data going from the guest through to the outside world. On the other hand, let's go back to our example where we're talking about a typical business application. So in a typical business application, you don't necessarily want to have all of that key management and QoS and control of that data. You just want an efficient, fast network just for the staff. So in which case you'd probably just use distributed mode and configure the access points accordingly, and then the client, the employee traffic obviously then bypasses the controller and goes straight to the actual outside world. And this is doing a mixed environment. So in a mixed environment where you've got guests and employees, you want to mix some centralized traffic and some distributed traffic. Now the key thing about this, and I didn't appreciate this when I first started looking at this, it took a while before I realized what was going on here. The key thing about it is an access point can talk in both centralized mode and distributed mode at the same time. The difference is the SSID. So when you go through that previous screenshot where I showed you setting up SSID policies, you can set up SSID policies which are centralized, and you can set up SSID policies which are distributed. And the access point can actually push both SSIDs out at the same time. So obviously if you've pushed out an SSID using centralized, then all the traffic from the guest goes through the access point, is then forwarded through to the controller, and only then makes its way to the outside world. If you're using distributed SSID, then in this example, you don't want the guest to be able to see the server, so they've used the different VLAN tags. So we distributed the actual traffic from the client, goes to the AP, and the AP routes it, in this example, for example, to the server, but it's not going through the controller. And this is just ramping up a whole different level. This is a hotel with 3 different classes of users. VLAN tags asunder and all sorts going on here. But in this instance, what they've said is, right, well, we want two distributed forwarding SSIDs, and we want one centralized forwarding SSID, each with different VLAN tags, and as such, the traffic flow is being controlled and managed by those VLAN tags. So in this instance, these two SSIDs bypassing the controller for traffic and being routed accordingly, and taking into account the restrictions of the VLAN tags. So the guest traffic can only go to the internet gateway, whereas the employer traffic is able to go to the employer's server. And the manager traffic actually uses centralized mode, which is all routed through the controller. So the other example that they brought in here is by the trick of using VLANs, so that the different types of users actually get an IP address allocation from a different DHCP server. So in this instance, if there's a DHCP request by any of the employers on this SSID, then the request comes from this server here, which has got the same VLAN tag as they have. In this instance, if it's a guest traffic, they get their DHCP reply coming from the main internet gateway router, yet again based upon the restrictions set up by that VLAN tag. By the way, trying to set this up must be an absolute nightmare. God. Okay, cross-subnet and cloud operation. The AC3000 will actually manage and control access points across subnets. Now, those could be across local subnets, or they can be across subnets actually separated by the internet. So this is a typical example where the controller's on one subnet, but the access points are on a different subnet. So the controller is able to manage these access points between different subnets. In this example, we've taken that upper level to extreme, where the controller is actually separated by the clients through the internet, yet again on a completely different subnet. Now, the approved way of doing that would be you actually had a VPN link between these two gateways. So that also meant that the traffic between the controller and the access points would actually go over a secure tunnel between the two sites as well. Now, the only thing to bear in mind is if you were trying to use centralized forwarding mode for this, you might find it a real pain in the bum, because that would mean that all the client data would have to go back this way and through the internet to that. So in my opinion, you couldn't use centralized forwarding if you were using this sort of structure where the internet was the main link between the controller and the APs. So it's got an advertising portal or captive portal. Now the main difference between the AC3000 type of captive portal and the normal run-of-the-mill captive portals is really the AC3000, or the purpose of the AC3000 portal is as an advertising push method. It's not the sort of thing that you would typically see on caravan sites, you know, where you have to pay for a ticket and you get so much internet access and all that sort of thing. It's really there as an advertising tool. So the sort of thing where you go to a hotel, you know, it's like you go to a hotel, you connect to their Wi-Fi, first thing, you get a barrage of adverts and you have to go through those adverts. And then some hotels, what they do is then they repeatedly hit you with the adverts after certain intervals of time. That is the sort of thing that the AC3000 can do. That's what it's aimed to do. And to that extent, it's very, very powerful. It supports simple advertisement delivery without any password required. It can also do the same thing, but with some form of password authorization required. And what it can even do is it can do different types of delivery per access point or per SSID. So each SSID can have its own different advertising portal associated with it. Take it a stage further, it can even have its own different advertising portal based upon the client device. If the device is a Windows desktop, it gets one particular portal. If it's an Android product, it gets a different protocol. If it's an Apple product, it gets a different protocol, a different portal. So different adverts based upon the AP, the SSID, and the specific hardware of the client. Very, very powerful. I struggle, to be honest, to come up with examples where you would need that degree of power, but the functionality is there. So let's go to the next screen. I'll just go through a few typical examples. So typical example where you want no password. Hotel needs to have a Wi-Fi network, but it wants them to be subjected to an advertisement. And from that point on, don't have to worry about a password. So that's a typical example there of a no password scenario. Yet again, same thing, but adding the password requirement onto it. And that's it. I thought there was another screen. There's not. That's it. So there, I've been through a PowerPoint on the AC3000. A bit rushed. I say a bit rushed. I don't know how long this video is, but I bet it's probably at least 3/4 of an hour or something like that. So a bit rushed. The real purpose here was to show you some of the key enhanced features that the AC3000 is capable of and how it differs from other controllers that you may have come across, and the brothers AC1000, AC2000 controllers that are part of the AP COM range. So a very powerful controller aimed at a different sort of market than we've traditionally come into contact with. So this is very large scale enterprise type applications. These are the sort of places and organizations who typically would have gone for a Cisco package using centralized forwarding or fit access points. So it has a lot of the functionality that you would see on those high-end Cisco managed solutions, but of course at a fraction of the price. You know, the AC3000 range, off the top of my head, I think it starts about £600–700 or something like that. If you were to try and look at the Cisco product, you're probably looking at 4 times that price starting point for the Cisco equivalent controller. So very powerful piece of kit, quite a niche market in my opinion, but the functionality is there. Now, what I'm going to do is we'll publish this video, and what I'll have then is I'll go through and reacquaint myself with the configuration and hands-on playing around with the AC3000, and then hopefully before not too long, I'll do another video which shows you the hands-on playing around with the AC3000, and I'll go through some of the aspects that we've done in the PowerPoint child and show you exactly what that means when you start playing around with the graphical user interface on the AC3000. However, for now, that's it. My name is Steve Mace, and I hope you've had a grand time. Thank you very much.